Okay, so this is just a brief overview of the unit circle. The unit circle is simply just a circle with radius 1. This circle has the equation x squared plus y squared equals 1. We use this unit circle in order to define 6 trigonometric functions, which will be of great use in science and engineering. First, we define a point along the circumference of the circle to be P equals our typical point x comma y. X comma y referring to the coordinates of this point on the Euclidean plane. Now, the first trigonometric function that we'll define will be x. So, x is going to be equal to the cosine of theta. The second trigonometric function that we'll define will be sine theta. Y equals sine theta. Okay, simple enough, except what is this theta? What does theta represent exactly? Well, theta is going to represent the angle between the x-axis and our radius that leads to the point on our circumference. This angle here, we represent theta. Okay, so we've got 2 trigonometric functions. Now there's a third trigonometric function that we can define. We'll look at the ratio between y and x. Y divided by x, we're going to call this tangent of theta. Now, this raises the question, if y divided by x is tangent theta, what's x divided by y? Well, x divided by y, we'll call this function cotangent theta. Great. So notice, cotangent theta and tangent theta are actually reciprocals of each other. We've just swapped the numerator and denominator of this ratio. That begs the question, if tangent and cotangent are reciprocals, well then what's the reciprocal of sine? We'll write 1 divided by y is equal to 1 divided by sine theta. And this function 1 divided by sine theta, we're just going to call cosecant theta. Similarly, we'll define our 6th trigonometric function by looking at the reciprocal of cosine. So 1 divided by x is equal to 1 divided by cosine. And this function 1 divided by cosine, we will call secant theta. Now, some useful properties about the trigonometric functions is they hold a property called periodicity. Now, periodicity means that these functions repeat after every so often. They're cyclical functions, and specifically, cosine has the period of 2 pi. Likewise, all 3, sine, secant, and cosecant, have the same period, 2 pi. So that was cosine, sine, cosecant, and secant. Cosine, sine, cosecant, and secant all have period 2 pi, which means that after a rotation all the way around the circle, you're essentially back where you started and the values repeat. Tangent and cotangent, however, have half this period. Tangent's period is pi. And like I said, that's the tangent function and cotangent function with period pi. One interesting result of defining our trigonometric functions in this way is that if we look at this equation of our circle, x squared plus y squared equals 1, we notice we can make a substitution. Well, x equals cosine theta and y equals sine theta, so why not substitute x and y in the equation for sine theta and cosine theta? So we'll see, substituting x and y in, we have cosine squared theta, and let's just note that this is the same as writing cosine theta squared. Cosine squared theta plus sine squared theta equals 1.